The second part of today's lesson is with respect to curve sketching, and this sort of pulls together a lot of what we've learned in this unit about the first derivative test, the second derivative test, critical numbers, understanding the relationship of a function and its derivative and its second derivative. So let's get started, and we're meant to do this entire problem without a calculator. So the first question is, find the critical numbers of this function f. Well, to find the critical numbers, we have to first differentiate f and then find the zeros and the undefined spots on the first derivative. So our function is a polynomial, so we can use the power rule to differentiate. So we get 4x cubed minus 12x squared minus 16x. Now, this derivative here is a cubic function, so there will be no spots where it is undefined. So we really just need to find the zeros of this cubic function, and I'm going to do that by factoring. Factor out a 4x leaves me with x squared minus 3x minus 4, and if I further factor, I get 4x times x minus 4 times x plus 1, and my zeros are going to be at x equals 0, 4, and negative 1. Those are the three critical numbers of the function. So part 2 says the function has exactly one local max, and it wants us to use the second derivative test to find it. Explain how you know that you actually have a relative max at this critical number. So that means basically to interpret the second derivative test in words. So to do the second derivative test, we need to take the second derivative. So I'm going to take the first derivative that I had in part 1 and differentiate it, again with the power rule. And I will get 12x squared minus 24x minus 16. And so what they want us to do is then plug in each of the critical numbers into the second derivative and determine where the second derivative is positive, because if the second derivative is positive, the function is concave up, and you have oops, I'm realizing we don't want a local min, we want a local max. Never mind. We want to find out where the second derivative is negative, because if the second derivative is negative, the function is concave down, and there is a local max. So I can just plug in each value, f double prime of 0, this is the easiest one to plug in, is negative 16, and negative 16 is less than 0, and therefore I have a local max at x equals 0, but they want us to find the local max. That doesn't mean where is it, it means what is it. So I can say it's at x equals 0, but I have to take 0 and plug it into my original function. So my local max is equal to f of 0, which is equal to 1. And that is because f double prime of 0 is negative, so less than 0, so f is concave down, and we have a local max. And really the only piece of that you must state is that you have a local max because the second derivative is negative. I'm not even going to check for a negative 1 because we were told there was exactly one local max, and I've already found it. So now it says the function has two local mins. Use the first derivative test to find the larger of the two. So the first derivative test tells us that we need to create a number line. So we're doing a number line analysis using f prime. We put in our critical numbers on the number line. We have negative 1, 0, and 4. So let's plug in a value to the left of negative 1, say negative 2, and let's plug it into the factored form of our function. If I plug in a negative 2, I get out a negative times a negative times a negative, which is negative. If I plug in something between negative 1 and 0, say negative 1/2, I get out negative, negative, positive, which will give me a positive value. Let's plug in 1 to represent the numbers between 0 and 4. That gives me positive, negative, positive. So that's a negative. And then let's plug in 5. I get positive, 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 which is positive. So the local mins occur where the first derivative changes from negative to positive. So I have local mins at, and again I say at because this is where they occur, not what they are. So they're at x equals negative 1 and at 4. So in order to find out which one is larger, I actually have to go back and plug them both up into here. So I need to find f of -1. And when I do that, I'm going to get 1, let's see, plus 4, which is 5, minus 8 is -3, plus 1 is -2. My other local min is f of 4, and I have to plug that in, and I'm actually going to take a minute to do my computations and hit pause. Okay, I'm back, and that wasn't so bad because my first two terms actually cancel out. So I just have -8 times 16, which gives me -128, plus 1 is -127. So the question was, what is the larger of the two local mins? Well, the larger is the least negative in this case. So the larger of the two local mins is -2. And it says, explain how you know that you have a relative min at this critical number. The way that you know is because f prime changes from negative to positive. And you have to put that in writing. You can't just let someone interpret the number line because the College Board readers actually ignore the number line and they look only for what's in writing. Okay, now they're telling us that f double prime equals 0 at these two values. See, they didn't give us a calculator, so they had to give us these values. So it says determine the number of inflection points. What we're going to do is do a number line analysis here on our second derivative. So I labeled my number line as the second derivative. I'm putting in a -0.528, and I'm putting in a 2.528. Those are the two zeros of the second derivative that they gave us. And now I just need to determine on the number line whether the signs changed in each of these intervals. So let's try plugging in -1 into the second derivative. And my second derivative is up here. If I plug in -1, I get 12 plus 24, which is 36, minus 16, which is a positive value, 20. Then if I plug in 0 from this interval, I get out a -16, so that's a negative number. And then if I plug in 3, I'm going to get 12 times 9, which is 108, minus, let's see, 72 minus 16. So I've taken 108 and I've subtracted out 88, so I have a positive 20 again, and that is a positive number. So the second derivative changes signs twice. So I have 2 points of inflection on f, 2 POIs on f, because f double prime changes sign twice.